Hello everyone, welcome back to the channel. In today's session, we are going to understand Kubernetes controllers and deployments from the scratch. We will see what they are, why they are needed, and where we can use them in the real-time environments. Along with this, so we see the live demo also, where I will show you how Kubernetes continuously compares the desired state with the actual state and automatically takes the action whenever there is a difference between those two states. So let's get started. Before we begin, let us quickly understand what we need. You should have one Linux server, whether it is a Ubuntu, CentOS, whatever it is, and we need one Kubernetes cluster. It can be Minikube or it is a cloud cluster like EKS, AKS or GKS. And we need to install and configure the kubectl. Okay. So the agenda of this session is, so majorly we are focusing on controller and deployments and replica set and how to do the scaling. And we will see rolling updates and rollback. And then finally, we will see the live demo with the practical example. Okay, so this is how we are splitting up this session today. Kubernetes works on very important concept called desired state versus actual state. Desired state is what we defined in the YAML file. For example, how many pods should run, which is called desired state. Actual state is what is currently running inside the cluster. This is called actual state. So Kubernetes continuously compares these two states. If there is any difference or mismatch, Kubernetes eventually take action to fix it. So this is the core idea of the Kubernetes. So then let's see, in the previous session, we understand that the pod is a singular, which means it doesn't have the ability to scale or replicate. The main purpose of using Kubernetes is to help us to scale the applications, right? If I need multiple copies of pod, so once again, you should be just telling to the Kubernetes, like I need 5 copies of the pod or I need 5 replicas. So you don't even have to define it, just tell to the number and the Kubernetes should be able to do it, or Kubernetes will scale it. So again, scaling means there is a scaling up or scaling down. Okay. And another thing is you need to have the ability to replicate. So what is mean by replicate? Now, let's say whether you want 2 parts or 3 parts or more, making the copies of that is the one, or but at any time you need to same number of parts are running. So if a part get crashes, we need the ability for the part to recreate itself or replicate itself. So this is how, even when we take any environment like staging environment, CI, QA, we will be running minimum 2 replicas. That 2 replicas should always running. So that is what Kubernetes has to take care. So now for that, pod alone doesn't have the feature to maintain the replicas. Now specifically in Kubernetes, we have a object to help you to do the replication. So these objects are called as a replication objects or replication controlling objects. The main purpose of replication object controller is take a pod and help you to scaling it or help you to replicate it, which means now you will not create a pod directly. You will have to define a replication object and that replication object to create the pod. So now the first thing is you need to create this replication object. So for this object, you need to tell what is the specification or what is the template of a pod. Because if I tell to create 5, what it exactly to create 5? That means 5 copies of the pod. You have to tell in the pod template, right? So to do this, I need to provide the input to the replication controller. So they are what is the pod template and what is the replica number. However, how does the replication object manages your parts? For example, if I tell that create a object like replication controller, what it will do is the replication controller object will create a part depending on how many replicas you give as input. But how does it knows that? For that, you have to give the replicas number in the spec. Internally, while creating a part template, you will give a label so that using the same label, it will be selecting. I wanted to make sure two parts are available, but what are those two parts? There should be a label matching. So that is how the replication controller object will take the help of a label to find out whether how many replicas you wanted is there or not. So that is how, if you see the labels which is being used in the code by the replication controller object to manages the parts, so that it's find out whether it is running or not. Even if you give one replica, two replica, three replicas, it will manage one replica or two replica or three replicas always running, so that you can scale up, scale down, all those things you can do it. Now, once again, this replication controller is the first type of object in the replication concept. But slowly, what happened? We wanted to some additional feature. For that, we are not going to once again use the replication controller object directly. Okay. Instead of replication controller, we will now use the three types. One is called as a deployment, another object is called as a daemon set, and the third one is called as a stateful set object. Now, this is when earlier we were using the old object called as a replica set. So this was helping the parts to scale up, scale down, and replicate. But right now, we are not going to use this directly. Instead of this, we have to use any one of these three. They are deployment or daemon set or stateful set based on the requirement. Now, when we need to use these three objects, so we need to know the difference between those three. So for that, let me also introduce another concept. When you take an application, usually depending on how it is going to help you, what functionality it gives, we will tell that as a front end or the application layer or backend application, correct? But you can also divide the application depending on the nature as a stateful application or stateless application. So what is mean by stateful application? Suppose you have a server or mission. Now you are running application on that server. That application needs to store some details or some data. And if it is stores the details in the same server or same mission, that is in the memory of the server where it is running, then that application is called as a stateful application. Now what happens here? You take this application, run in another server, it will run, but is that same what we have in the previous server? It will not same. Every application has its own state, okay, because data stored within the same server. The best examples for stateful applications are database servers. They are MySQL, PostgreSQL, and other database servers, and SonarQube. Because when you install a database, it stores the data in the same server. So now, if I take the same database and install in the some other server, the data will be different. That is how stateful application where it maintains the data in the memory in the same server. And then comes to the stateless application. So stateless applications are those where the data of that application will not be stored inside the server. It will be stored on somewhere outside the server. Like it could be another server or another database. So those are called as a stateless applications. For example, all front-end applications are the stateless. I can connect all those my front-end applications to the DB. Whichever front-end you connected, you will get the same data. That means the state looks the same. That is why we will call this application doesn't have its own state, because it gets the state from the outside the database. Okay, this kind of applications are called as a stateless application. So usually all your front-end applications are stateless applications, not even front-end. Some of your application layers are also stateless application, because whatever the web applications that you are accessing, you are connecting to the front end. So that is where your Amazon, Google, LinkedIn, Facebook, you connect from the laptop or mobile. What will happen? You will get the same data, because where is LinkedIn, Facebook, and Google storing the data? Not on your laptop or not on your mobile. It will storing in somewhere else, right? So those kind of applications are called as a stateless applications. Okay. Now the difference here is, instead of server or mission, we are going to run a application inside the container. So if you are running a container and inside the container there is a application, an application storing the data inside the container, then that application we can call it as a stateful application. If you are running an application in which the application is running inside the container, where is the data is stored on outside of the container. So these type of applications are called as a stateless application. So that means if you are trying to run all your microservices applications or front-end applications inside the container, they are called as a stateless application. So now, why we need to talk about these stateless and stateful applications? Now, this is where I told you we have different replication controlling objects. Out of that, the first one is a replica set. So that is a old object, so we don't use directly. So the first thing is, suppose if you are deploying an application and if it is stateless application, and you should be using object as deployment object. Okay, so don't get confused with the word called deployment. So I am not talking about the application or container deployment here. The name of the object which is given by the Kubernetes, which is called deployment object. So when we should use this deployment object? When your application is stateless, which means if I give you Docker image for front end or application layer, immediately you should think to run this, what I need? A deployment object I need. Now, what is a deployment object will do? This is where the deployment object will create the replica set. Example, if you want to create and run the microservices for staging environment or test environment with the two replicas, you have to tell to the deployment object that created two replicas, which is called two parts, and then you have to give the templates and labels. Now deployment object will create the replica set, and replica set will create the parts. Now why deployment object has to create the replica set? We'll see now. Let's see how scaling and replication will happen. Now remember, you will create a deployment object. Deployment will create the replica set will create the parts. That's how when pod crashes, replica set should make sure to recreate it. If you want scale up or scale down, you tell that as a definition to the deployment object. Then deployment object send it that information to the replica set, and replica set should be take care of completely. Whenever I say deployment, you need to think of three things. One is what is the spec or template of that pod. what is the label of that part, and how many replicas. These three things you should need to be aware of that. Let's take an example. We will see the live demo now. Look at the YAML file here, or manifest file. It is the deployment file. It has the different version of APIs. So here apps/v1. Then metadata, you give a name here. I have given as a test-deployment. Then define the spec. This is where first we have to give replicas, which means how many parts that you want. I have given 2. Now ignore for selector. Later I will let you know. After replicas, what we have is the template. So what is template? Template means here pod. Okay. So whatever you gave it as a pod object, you have to put that entirely under the template. So we are telling for this deployment object, I need 2 replicas. So what is the template creating those 2 replicas? Okay. And here we will see another thing while we are defining the pod template, we are giving the label. So you can choose any label you want, and this is the same label you are going to give it as a selector. Why we need to give the same label? The template will create the pod, but how it is going to maintain 2 replicas of the pod? So it is going to select the label with the name of dev deployment by using the selectors. Okay. So the selector label and the pod label should be match. Here see. So that is how deployment object will know, okay, you want 2 replicas. I will make sure there are 2 replicas with this dev deployment label. So let's execute the code and now see. Kubectl apply-f deployment.yaml. It says created the deployment object. Kubectl get deploy and kubectl get rs. So you can see the deployment object has created. Another object called ReplicaSet also is created. And look at the naming convention here. Deployment name, then hyphen ReplicaSet name. What is the desired state here? Desired means it's a replica. So deployment object has created the replica set. Now if you go ahead and say kubectl get parts, who has created 2 parts now? Look at the naming convention here. So this is called deployment name, and this is the replica set. This is the pod names, which is called random names, which is given by the Kubernetes. Now who is the created these parts? Deployment has created these parts. Who is the parent for this part? A replica set. Who is the parent for this replica set? Deployment object. Okay. You can also cross check the labels. Kubectl get parts -show -labels. See here, the labels also dev environment. Part template has the labels. Okay. So now watch the difference. Now see the difference. If one of the part get deleted, it has to replace the a new part. Let's deleted one part. Kubectl delete part. I can give the part name. But however, the part gets deleted, the replica set will be finding that I wanted the label to match with the 2 parts by selector, but there is only one, so it will try to create another. Once deleted the part, quickly check now here. Kubectl get parts. What happens? It replaced with the new part. So everything remains the same. If you want, you can check kubectl get rs, kubectl get deploy. See here, everything should be same, nothing is changed. Now let me edit the deployment.yaml file and change the replicas 4. So I given 4 and I am saving this. So you have Kubernetes commands to change the scaling, but since we are using declarative method, it's always good to update any changes you want in the YAML file and then you can apply. Because here I am directly editing the file, but in the real-time projects, we are going to store all the YAML files to GitHub or Azure DevOps or any source code repository. So only when someone commits the code from your feature or developments branch to the target branch, the code will be tracked, right? Then the pipeline will be triggered. But in the coming classes, we will see how to scale up the parts by using kubectl commands. Now kubectl get parts, kubectl apply -f deployment.yaml, kubectl get parts. Now it is see running. 4 parts are running now. Kubectl logs -f. You can give any part here. Now see the logs are printing here. Kubectl exec part name, then cat space /etc OS release. See, this is the version of the OS 24.04 it is using. Okay. So now what we can do, we will discuss about the rolling updates and rollback. See, rolling update means whenever there is a change in the application, so we are going to rebuild the Docker images. That time the image tag or image version should be changed. So after that, we can update that image version in the YAML file and we can apply it. So that time it will goes from old version to new version. Once that version is changed, that means rolling update is done. If any issues found in the newer version, we need to go back to the older version again. So that case we can use the rollback. So we can use rollout or undo. We can go to the previous version. Let's see it. So let me go to here, VAM deployment.yaml. Here earlier we used latest version. Now I'm going to use 22.04. Okay. Then this message also I need to do echo message second dev environment deployment, then save it, then kubectl apply -f deployment.yaml. So this means delete the old part and create the new parts. This is called rolling updates. Kubectl get parts. See here, terminating the old parts, that means it's deleting the old parts and it's creating the new parts. So this process is called rolling update. So if changed the old one and it's created the new one. And you can check here, kubectl logs -f. See here, this is the second dev environment deployment. We have changed the echo message also. And even kubectl exec pod name cat space /etc OS release. See here, the version should be 22.04. Earlier, it was there 24.04. Okay, so that means rolling update, it was happened successfully. So look at here, what is happening. kubectl get rs. What do you understand now? There are two replica sets. One is a old and another one is a new. Old replica set will pick up the template from the Ubuntu latest and printing the message is first dev deployment. Whereas since we changed the template of the pod, then what deployment is doing, it create a new replica set to track. And that is the reason it disabled the old one. That is why the pod got terminated and it is enabled the new replica set. Now, what is the template of the new replica set is Ubuntu 20.04 and printing the message is second dev deployment. Okay. So this way, what deployment object does for every change that you do in the part template, it will be maintaining the copy. By default, it will maintaining around 4 to 5 copies, but you can also change it depending on your need. Now, what is the necessity to do like this? So let's assume in production, you changed old versions to the new version, but for some reason, immediately you are getting some error. So what you should do? You should do rollback. So what is a rollback? Like how you do rolling update, that is changing the older version to newer version. The rollback is changing the newer version to older version. Now this is where every time you need to update the YAML file and then you need to apply. Now let's say you have done small changes, okay, but what if we have done multiple file changes and multiple line changes in the YAML files? Then that case we need lot of support is required. Then it will be difficult to change everything here and then apply. Whereas in production setup, rollback is very fast. And that is where the benefit of using deployment object is with the help of ReplicaSet, it is going to create the parts and run the parts. Additionally, what a deployment object can also do is that will help you to roll back and rolling update. That is where you can run the commands like kubectl rollout status deployment, and you can give the deployment name. See, this has rolled out. Now this will work only for your deployment object. If I say rollout history, so it will tell how many times this has been changed. So revision means 1 to 2 times it has changed. What was the first time? The first time is Ubuntu latest, and printing the message is first dev deployment. Whereas the second revision is Ubuntu 22.04 and printing this is a second dev deployment. Now you can also give the comments here. Technically, we can call it as a annotations. So instead of none, we can give the annotations. Later, we will see some example. So you need to understand annotations means giving some comments wherever you need. For every object, you can give it. Okay. So now how can we roll back? So that's where without worrying about that was the earlier, we definitely know that the previous one of the replica set and the number corresponding to it. If I give one and if I run, let's see what will happen. So I can give rollout undo deployment, but here make sure -2 revision is equal to 1. What object you want to undo? Let's see. To which version you want to undo? So I have given here 1. If you don't tell the revision, will immediately take the previous version. Example, if there are 10 versions are there, if you did not mention the revision, automatically it will go to the previous version. So what will happen if I run this? It will enable the old replica set, create the new part, and as soon as new part created, it will make 0 for the latest replica set. So kubectl get rs, see latest should be 0. Kubectl get parts. Now it has created the new parts. So that is called as a rolling update because internally it does not know what you are doing, but you are asking to roll back, which is called undo or rollback. So you can old replica set got some number which is 4 and now new replica set will got it as a 0. And you can also cross check now kubectl logs -f. You can give the pod name here, paste. Now see first dev deployment, and here -cat space /etc OS release. Now it should be 24.04. See here 24.04. Okay, so this is the benefit using deployment object. So basically now if we understand what is the deployment object and what it is going to do. So with help of deployment object, we can do the scaling, replicate, and rollback. But when it is used, it mainly used for deploying any type of stateless application. So that's how you should start remembering. Obviously, you need container. On the container, you need pod, but you need the ability to pod, to scale, replicate, and if it is a stateless, then you should think of defining it as a deployment object. So remember, you will not handle pods directly. But now, how many objects we are created now? So there are 3 objects. They are deployment, a replica set, and pod. Finally, if I delete the parent, what happens? It will delete entire. kubectl get rs, get parts. See, it is terminating. Get deploy. See, nothing is there. It got deleted entire. So this is how we are going to create deployment, replica set, and parts. So if any doubts, could you please comment in my channel? If this video helped you, could you please comment, like, share, and subscribe. Thanks for watching. So in the coming video, we are going to see daemon set.